So if I say MEI equals MEF, what kind of ME does it have at the top? Yeah, it's PEG, right? And what type of ME, mechanical energy, does it have at the bottom? Hello, obviously. Start on the hill, get to the bottom of the hill. What kind of energy you have? Kinetic, right? Now, that part we should be like, okay, yeah, I get that. If you slide a block of ice down a slide, right, it's going to have KE. But is that the only thing that this has?
No.
How else is it moving? It's spinning. Well, okay, true, you're right. Gravity is what makes it move. But do you see, if it rolls down the hill, it's not just translating or linear moving, it's rolling. It's rotating. Does that make sense? So you have to do this. Okay, and now I just start going nuts. MGH equals 1/2 mv squared plus 1/2. What is m in rotation? I. And then what is v in rotation? Omega squared. Now, what is I for a ring? It's actually mr squared. Now think about what I did before. Remember I said, if, like I said, for some mass, you have to take the sum of all of the moments of inertia for each of the pieces of the mass. But think about it if it's a ring. Remember before, I had this sort of pizza situation going on.
Is it empty in the middle?
Yes, it's empty in the middle. Do you see? So do you see that it's perfectly reasonable for me to approximate that each one of these chunks is just m? Well, actually, it would be like m over 8. Does that make sense to you?
Yeah.
And do you see that that piece pretty much has the same radius? Right? So, I mean, we're assuming that, it's thin ring, whatever. If that's true, then that means this moment of inertia for this is mr squared, which is going to be m over 8 times r squared. What's this one going to be? Same. M over 8 r squared. This one? This one, this one, this one, this one. How many of them?
All of them.
There's 8. And what's 8 times that? That's it. So the reason is because it's hollow in the middle. So that allows me to say, because of this, and what do we also know about omega, please? Omega is what? V over R. Very good. So we have m, and what mgh equals 1/2 mv squared plus 1/2 times mr squared times v over r, or v squared over r squared. I can cancel out the m's. I can cancel out these r squareds. And I'm left with gh is equal to v squared over 2 plus v squared over 2. So do you see, where did half of the energy, all this potential energy broke up into two things, and they're both the same magnitude. And when I convert them, what I get is gh equals v squared. Does that make sense? So you see v is the square root of gh. Now, if you are falling, and you fall a distance h, what is the equation for your velocity? Do you remember? Starting with an initial velocity of 0, using gravity as your acceleration. Do you remember this equation? Right? That's 0 because you started with that. So Vf is equal to the square root of 2gh. Does that make sense? Do you see? If you were sliding with no rolling, do you see that you'd end up going faster? Right? Do you see what I'm saying? If you were sliding down with no rolling, you would end up going faster. Well, not twice as fast, but about 1.4 times as fast. Because the rolling uses up some of the energy.
So if it wasn't like this, it just slid like that.
Yes.
It would be faster.
Mm-hmm.
Do it again. If it's rotating
So like this thing, can you see this? If it slid down, like see the little line across there? If it slid down the hill like this, when it got to the bottom, the velocity would be square root of 2gh.
Is that possible?
Yeah, if you made the hill like frictionless.
I could
Like
see
so
that.
it's ice.
Yeah, like if it was ice and this was really heavy, then when it slid, it wouldn't rotate hardly at all.
Oh yeah.
I mean, have you ever done bowling where you throw the ball so hard that it slides?
Yeah.
Yeah. Like you go, wah, and then like it's like, and you can read it. You can see the ball go. Yeah, it's like a really light one, right? Because you can throw it really fast. So the velocity and the inertia is much bigger than the force of friction.
And also, don't you have to like?
Yeah, you have to let it go like this. Like, yeah, you can't turn it. If you turn it, then it'll spin.
So when it rotates, it means it goes slower than.
Yes, because you use up some of your energy to make it rotate. Yes.
Oh, what was the point of like all that stuff when all we needed to find velocity was just the
Oh no, we couldn't. See, it's not the same. Look, you see this is 2gh, and that one's gh.
Wait, so this part was useless.
No, this one.
You're confusing me.
This part, okay, was to show you that this is what would happen if there's no rotation. And that's what happens with rotation. And it was to show you that it just kind of makes sense if you think about it. That because if there was no rotation, all of the potential energy goes into moving that thing down the hill. So it's going to go faster. But if there is rotation, then some of that energy had to be used up to make it rotate, and therefore its linear velocity is lower. Does that make sense?
Yeah.
Questions? Anyone else get confused by that last bit? Sorry. Okay.